Hey everyone, welcome to part 4 of Breaking into Web Hacking in 2024. Today we're going to attack databases using SQL injection attacks. If you're not familiar with SQL, it stands for Structured Query Language, and it is commonly used by applications to make any changes to a databases or check for any sort of input and see if it's actually there in the database. Uh, so to get started, we are actually going to do an apprentice level lab first. This one we're going to do is called SQL Injection Vulnerability allowing login bypass. So there's two ways of getting a login bypass through SQL injection. So we're going to test for both of them here. So let's start the lab. Let's just access it. And while it's loading, I want to give you guys an idea of what goes on in the background because SQL commands and queries typically happen in the background or in the back end of the application. So you won't really see these statements as a regular user clicking around stuff and they're typically in this format. So here we got a select, and the asterisk is saying it's selecting anything from a table called users, where username is whatever input we give it, and the password is whatever password we give it. So in this case, what we're saying is we're going to have a database. Let's assume the first one's an ID parameter. Um, let's see if we have a okay. Was checking to see if we could build a table here, but it looks like we can't. So we're just going to keep making this makeshift table here. So we'll have the row, the column here with ID. The next one is user name. And the next one is password. Um, and just to give a quick example here, this is what a database would look like for authentication. So the username, let's say we'll call that admin. And then the password would just be, let's say password one. So this would be a row within this database. And in this statement, if a user inputs, let's say admin with the correct password, it will check the row. It would see, okay, this is true. And it will allow the authentication to go through. So a couple things to look at in this statement here. We are seeing this input is our input, and it does use a single quote. That's going to be important for us to remember when testing for SQL attacks. And then at the end, we have this semicolon. So what the semicolon does, it closes the statement, letting you know that that's the end of the statement and you're ready to have another select statement right here. So now that we got that sorted out, we got the lab loaded up. Let's fire up our burp. And let's read back that lab. I kind of just brushed it over real quick. So this says this lab contains an SQL injection vulnerability in the login function. To solve the lab, perform an SQL injection attack that logs into the application as an administrator user. Cool. So let's go back to our lab here. So it's still loading. We're going to control copy this for when this finishes loading. Cool. Let's go to our proxy. And we are going to, again, just open up the pre-configured browser here. So I clicked it once, so let's just click it again just in case. It's taking a little bit of time there. One more time should do it. And let's see. While it's loading, we are going to just see the login here. Admin. Actually, it looks like our Chromium browser popped up, so we're just going to take this login URL, control copy it, and bring it to our Chromium browser. Again, this is the browser that we're able to proxy the traffic from, the HTTP traffic. So we're going to control V. Oops, I did it twice. Boom. Let it load. And we're just going to give it a simple administrator. It's already here for us. Password. We're going to make the password test. Boom. So we get an invalid username or password. So when doing any sort of SQL testing or testing for this kind of specific vulnerability, what I like to do is if we go back to the statement here, um, any function that's vulnerable to this kind of attack will take the user input exactly how it is and put it right into the SQL statement that that happens in the back end. So in this case, if we just grab this single quote, we're going to go for a administrator in this case here, and we're going to put one single quote to see what happens. And we get an internal server error. So what that tells me as a pen tester is that in the background, the backend function did not process this as expected, meaning that any sort of function here that is processing this specific input for us is not sanitizing what we give it. In other words, if we give it a single quote, it's going to treat it as a single quote here. So if it puts this right into the SQL statement, what this looks like is we get our input, and then we're also getting a second single quote. So as we can see, this is not a proper syntax for the SQL statement, having two single quotes here before the and statement without any sort of data. And that's exactly why we're getting the internal server error in this case. So now that we know that that is the input that is vulnerable to an SQL injection attack, just so you guys can see what it looks like on the HTTP traffic. Here's a vulnerable request. We are just going to send that straight to repeater. Repeated. All right. It's right here. We get a little URL encoding. So the first test I like to do to see if it is vulnerable to a login bypass is once we put in the single quote, we are going to use the double hyphen here, the dash dash. In SQL statements, this is considered a comment. So if you're familiar with programming, whenever you introduce a comment, it means that anything that follows the comment statement is no longer considered as part of the statement. Meaning that in this situation, if the comment works out, what this new statement is going to be is select from users where username equals this. In this case, we're going to just put administrator. And we're going to put the hyphen right here. Apply the changes, and we're going to send it straight out. Boom. So it does look like we successfully log in. We did turn the that 500 into a 302 and with a redirect. We're going to follow the redirection. Another redirect. And we get to a final 200 page right here. We're going to render it out. And if this works out as expected, we should be logged in. So we still have it not solved. So let's go back to our Chromium. And what we are going to do is we're going to see if we could just do it right here. So password could be anything. Again, if we're commenting out the rest of the statement, it doesn't really matter what we give it as a password. Invalid CSRF token. Okay, so there must be some sort of cache issue here. So we're just going to refresh it, get a new CSRF token. All right. So it's looking like the CSRF token is just sticking around. So we're going to go to the base page, my account. Looks like it saved our previous statement here. And we're going to give it a test. All right, this should work out for us. We're never saving this. Beautiful, it's solved. So that gives us a little introduction of how to create the, how to test for SQL statements. So again, just repeating what we did here. First, we added the single quote to see what the response was. In this case, the 500 is what gave us a confirmation that there is an SQL, potentially an SQL attack. And then by adding the comment to statement, we can see how this new SQL statement was formed and was able to let us log in just from the administrator name being somewhere that exists in this database. So to be honest, you're really not going to find this too much in the wild. A lot of companies have very pretty much tested for this, and there are tools that automate for this kind of attack. So it's really not that common, but it's still worth testing out. So what we are going to do now, we are going to do another lab. what I like about this next lab that we're going to do, so there's a bunch of other SQL injection attacks that I think are important for you to also do. Some of these are help you identify the type of database it is. As you can see, there's Oracle, MySQL, Microsoft, and all these different kind of databases will have different kind of syntax. So it's important to understand what kind of database you're attacking. In this case, I'll keep that for you guys to do on your own. The one we are going to be interested in looking at together is this one. SQL injection union attack, determine the number of columns returned by the query. So in this kind of attack, the main goal of this one is to identify how many columns there are in the database. This is going to help you actually create valid payloads. As we saw in the previous lab, if your syntax, if the backend functions creates a weird sort of syntax, you are going to get some sort of error and you're not going to execute the proper SQL injection attack you want. So in order for you to be able to create the valid attack, the valid payload, you are going to have to understand the kind of database you're attacking. So let's read through this. SQL injection union attack, determining the number of columns returned by the query. This lab contains an SQL injection vulnerability in the product category filter. The results from the query are returning the application's response. Cool. So I just realized we've been navigating this through the browser that is proxying the HTTP, not through the browser that I'm logged in. So we're just gonna move over here again for now. Let's see if this works out. This should launch the lab from here. Beautiful. So it did launch the lab. All right, so let's read through this again. This lab contains an SQL injection vulnerability in the product category filter. So I don't want to keep proxying PortSwigger. So what I am going to do is take the URL that we created that hosts our lab. And we're going to just copy and paste it over this Chromium. Cool. So the lab already told us the vulnerable parameter is the filter. So this is the refine your search. I'm assuming these are the filters here. So let's just go for something that GIFs. It's pretty short. Perfect. So we are going to run that same attack. So something to pay attention to here. Let's challenge ourselves to not use burp for this lab. We're going to pay attention to the URL parameter here. In this case, we have the category parameter right on the URL with GIFs. And I'm going to just put the single quote right on top. See what we get. All right, so we do get an internal server error. What this is telling me again is that an SQL query might be happening in the background and it wasn't in the proper syntax. So to perform a proper union attack, where you're doing two simultaneous select statements from different databases, essentially, you want to be able to have the same number of columns in these statements. In this situation, since we don't know the number of columns, what I like to do is I use the order by function within SQL to determine the number of columns. So if I use order by one, ideally there's at least one column, and it should be a valid SQL statement. So we'll do order by one, and we'll comment out the rest. Perfect. It worked for us. That means there's at least one column. Now we'll do order by two. Beautiful. There's at least two columns, and we're going to keep doing this until we're able to figure out the number of columns in the database we want to attack. Order by four. Cool. So pretty straightforward. We can see that direct change happening from 3 to 4. At 4, we get the internal server error, meaning that for some reason our SQL statement is no longer true. So what we are going to do here, let's look back at what the lab wanted us to do. So it does want a union attack. Okay. We know that there are 4. At 4, it causes the error. So we're going to go back to GIFs. Single quote, we'll do union select. So this is also another important thing to keep in mind when doing these sort of union attacks. The data types within the two databases that you are trying to do with this union select have to be the same type, meaning that you can't have a Boolean, like something like a true false statement, within the same that you're trying to get information from, be a string. So they both have to be either strings or Booleans or number or integers. Or in this case, what we are going to do, we're going to use null. So null is basically a placeholder for us. It basically is zero. It could be anything. It could be a string. It could be a number. Null is just nothing essentially, but it covers the ground for everything. So we saw that we needed 3 columns. So we're going to do 3 null statements. Well, 3 null values here. And if we get it right, we should have this lab solved. Beautiful. So we quickly, we had one solved and one unsolved, but we saw that we did solve this in the end. And we didn't even use burp suite for this. So I want you guys to keep in mind that we just essentially attacked this sort of SQL injection attack using the URL parameter category itself. You could also do it through burp, as we can see here. But this goes to show you that you don't always need the latest tools. It's just a matter of paying attention very closely to what it is you're attacking. So this was a quick snippet of SQL injection attacks. There are many more labs here to cover, but I thought this would be a great introduction for you guys to understand how SQL queries can be abused and how you can use them to be able to either bypass any sort of login or even be able to figure out more information from other databases. As you can see, there's a lot of different kinds of labs happening here for us, and there's a couple that I haven't even solved myself. One that I am really interested in checking out with you guys is this one. Let's see. We want to do this one. Blind SQL injection with conditional responses. But for the sake of time today, we're going to leave that for the next week so that I'll give you guys a week to really fully process this first part of the SQL injection attack. And just to kind of reiterate what we did in the process of how to test for this, we use a single column, the single quote, to figure out first if we get some sort of internal server error or some sort of like 404 response, something that tells us that the backend is not processing this the same way that it was with our other input. And then next, what we'd like to do is use the hyphens, the double hyphens, to see if we can comment out the rest of it. So tune in, guys, for next week to be able to attack more SQL labs, especially this blind SQL injection attack. I'm really excited for this one. But for now, guys, peace, bugs, and muscles.